Everything you know about the scale of the universe is about to feel tiny. We live in the Milky Way, a vast spiral of billions of stars. But compared to the monster known as IC 1101, our entire home is nothing more than a microscopic speck. Imagine a galaxy so impossibly large it could swallow thousands of Milky Ways and still have room to spare. And the strangest part is not how big it is. It is that the people who measured it still argue about where it actually ends. Tonight, we follow the light from that galaxy across 1 billion years of empty space, and we go looking for its edge. If there even is one. IC 1101 is usually introduced as the largest galaxy ever found, the brightest member of a cluster called Abell, 2029, about 1 billion light-years away, with a width sometimes quoted near 6 million light-years. Every part of that sentence is defensible, and taken together, they hide a problem deeper than the size itself. Because to call something the largest galaxy, you first have to know where the galaxy ends. And IC 1101 does not end. That is not a dramatic way of saying it is very big. It is a literal description of what its light does. The stars near the core blaze bright, then thin outward, fainter and fainter. And instead of fading into darkness at some clean radius the way an ordinary galaxy does, the glow keeps going. No cliff, no outer wall, only a slow dimming that slides below what any telescope can pull apart from the background, while still, faintly, being there. So, astronomers do the only thing they can. They choose. They pick a level of faintness, a brightness so low it is nearly the dark itself, and they declare that wherever the galaxy's light drops beneath that line, that is the edge. Change the line, and the galaxy changes size. Set a brighter cutoff and IC 1101 shrinks to something merely enormous. Set a fainter one and it swells outward by millions of light-years. The 6 million light-year figure is what you get when you trace it almost all the way down to nothing. These outer levels are fainter than the natural glow of the night sky itself, which is why measuring them is so hard, and why two careful teams can study the same galaxy and disagree about its size by a factor of several. The size is not something we discover, it is something we define. The stars carry no marker saying which of them belong. It gets stranger when you ask where those faint outer stars came from. Around a galaxy like this lies a vast dim halo of stars that belong to no single galaxy at all. They were torn loose from smaller galaxies that fell into the cluster and were pulled apart, and now they drift through the whole cluster, orbiting its center rather than any one home. Astronomers call this the intracluster light. In some clusters, these homeless stars add up to a large share of all the starlight present, tens of % of it, glowing between the galaxies with no parent. And the outer glow of IC 1101 blends into this drifting light so smoothly that there is no point where one ends and the other begins. The galaxy does not sit inside the cluster like a stone in a field. It dissolves into it. So the real question is not how big IC 1101 is. It is whether the line between this galaxy and the cluster around it exists anywhere in nature, or only in the choice we make when we draw it. There is a second way the thing refuses to hold still, and it has nothing to do with space. The light we measure left IC 1101 about 1 billion years ago. We know the distance because that light arrives stretched, reddened by the expansion of the universe by roughly 8%, and that stretch, read straight off its spectrum, is what fixes how far it has come. But it means the galaxy we are measuring is a snapshot 1 billion years out of date. When that light set out, Earth's oceans held nothing but single cells, and the first animals were still hundreds of millions of years away. 1 billion years is long enough for IC 1101 to have swallowed more galaxies, shifted its shape, grown a wider halo, And we would have no way to know, because the news is still in flight. We are putting a sharp number on the size of an object whose boundary is a matter of definition, made partly of stars that belong to nothing, seen as it was an age ago. 3 different kinds of softness, stacked one on the next. What stays with me is what all this does to the word galaxy. We use it as though a galaxy were an object, the way a planet or a stone is an object, with an inside, an outside, and a clear surface between them. For most galaxies, that picture works well enough to be useful. IC 1101 is where it quietly breaks. It shows that the neat boundary we imagine around a galaxy was never a feature of the universe. It was a convenience, and it holds only until you meet something large enough to expose it. The edges were ours. The galaxy never agreed to them. Even the distance is softer than it sounds. Because space expanded while the light traveled, IC 1101 is now farther away than the billion light-years its light took to arrive. The galaxy has drifted outward during the very time its own message was crossing to us. There is no single clean number for how far it is, how big it is, or what it looks like now. Every honest answer comes with a definition attached, and a date stamped a billion years in the past. Abell 2029 is a cluster of hundreds of galaxies bound together by a halo of dark matter that outweighs everything visible many times over, its space flooded with gas so hot, tens of millions of degrees, that it shines in X-rays. IC 1101 rests at the very bottom of that gravitational pit, and everything strange about it, the missing edge, the borrowed stars, the impossible size, traces back to that one location. The galaxy did not simply form there. The well made it, and the well is still feeding it. What does it take, over billions of years, to build something so large it stops being a single thing at all? We tend to imagine galaxies scattered across space at random, like grain thrown across a dark floor. They are not. Over billions of years, gravity gathers them into the low places, the bottoms of enormous valleys carved into the shape of space itself, and Abell 2029 is one of the deepest valleys in this whole region of the universe. IC 1101 lives at the very bottom of it. A galaxy cluster is the largest thing in the universe held together by its own gravity. Anything larger than a cluster is not bound at all. It is being pulled apart by the expansion of space faster than gravity can gather it back. So a cluster is, in a real sense, the biggest single object that exists. Abell 2029 is one of these, a gathering of hundreds of galaxies catalogued in the late 1950s among thousands of others, and it is unusually smooth and settled. That calm makes it one of the cleanest places we have to study how such a structure actually works. The first surprise is how little of it you can see. Add up all the stars in all those hundreds of galaxies, and you have accounted for only a small slice of the cluster's mass. We know this from the way the galaxies move. In a cluster like Abell 2029, the galaxies race past one another at close to 1,000 kilometers every second, fast enough to cross the United States in about 4 seconds. The gravity of the visible stars alone could never hold galaxies moving that fast. They would have scattered into the dark long ago. Something unseen is holding them down. This was first noticed in the 1930s, when Fritz Zwicky measured the speeds of galaxies in another cluster and found them far too fast for the visible matter to explain. His conclusion was that most of the cluster's mass had to be invisible, some kind of dark matter that gives off no light but pulls like everything else. For decades, the idea lived at the edge of respectability. Now it holds up the whole field. Around 85% of a cluster's mass is this dark matter, an unseen halo far larger and heavier than everything that shines inside it. The galaxies we can see are bright debris floating in a much greater darkness. All told, Abell 2029 weighs something like 1,000 galaxies, the size of the Milky Way, dark matter included, bound into one structure a few million light-years across. There is a second hidden component, and this one we can detect directly. Most of the ordinary matter in a cluster, the normal stuff made of atoms, is not inside the galaxies at all. It floats between them, a thin gas filling the entire volume, and it is searingly hot, tens of millions of degrees, thousands of times hotter than the surface of the sun. At that temperature it glows in X-rays, which is how we map it, and there is several times more mass in this hot gas than in all the stars of all the galaxies combined. The thing we see most easily, the galaxies themselves, turns out to be the smallest part of the whole. The gas does something for us. It settles into the gravitational well the way water finds the low ground, and the depth of the well sets how hot the gas has to be to keep from falling all the way in. So by reading the temperature of that X-ray glow, we can weigh the well itself. The gas works as a thermometer for gravity. The hotter it burns, the deeper the pit, and the gas in Abell 2029 burns very hot. Now the part that built IC 1101. A galaxy that drifts into a cluster does not simply join the crowd and settle into place. As it plows through the dark matter, the hot gas, and the gravity of every other galaxy, it drags on all of them, and they drag back. The galaxy bleeds its energy into its surroundings, its path decays, and it spirals slowly inward toward the bottom. Astronomers call this drag dynamical friction, and across billions of years it does to a galaxy what friction does to anything moving through a thick medium. It carries it downhill to the lowest point there is. And the lowest point is already taken. Whatever galaxy reached the bottom first becomes the collector, sitting at the focus of the well while everything that falls in eventually arrives at its door. That galaxy grows. It is always the brightest in the cluster. It is almost always the largest. It is old and red because it has sat there longest and ran out of fresh gas to make new stars ages ago. There is a name for this position, the brightest cluster galaxy, and IC 1101 is the most extreme example anyone has found. It did not happen to be big. IC 1101 has no clean boundary because it is not truly a separate object set down inside the cluster. It is the bottom of the well, wearing the shape of a galaxy. The stars in its faint outer reaches belong to the cluster as much as to it, swept down by the same gravity that holds everything else in place. What we kept hunting for the edge of was never a thing with an edge. It was the visible floor of a valley millions of light-years across. There is one more reason this particular well grew such a monster. Abell 2029 is what astronomers call relaxed. It has not suffered a major collision with another cluster in a very long time, so it has had the quiet it needed to settle, its gas cooling toward the center, its giant galaxy resting undisturbed at the focus. That stillness matters more than it sounds. Violence tears galaxies apart and scatters what they have gathered. A long calm at the bottom of a deep well lets one galaxy hold on to everything it catches, century after century, merger after merger, with nothing strong enough to break the collection back open. So far we have stood outside this thing, weighing it from 1 billion light-years away. Turn the view around, though. The bottom of a gravitational well this deep, packed with the oldest stars in the cluster, is still a place. Something standing in it and looking up would not see anything like the sky we know. What would the night look like from the center of a galaxy that swallowed all the others? Lie on your back somewhere dark, far from any city, and let your eyes adjust, and you will see maybe a couple of thousand stars at once. A faint river of light may run across the sky, the band we call the Milky Way. Almost everything up there is white, or bluish, or warm gold, scattered across the black in no order at all. That sky is so familiar we treat it as simply what a night is. Stand at the center of IC 1101 and almost none of it would be true. Start with why our own sky looks the way it does. We live inside a flat disk of stars, and that faint river overhead is not a separate thing. It is the rest of our galaxy, the disk seen edge-on from within, its far stars blending into a smear of light. We see a mix of colors because the Milky Way is still alive in one specific way. It is still making stars. Among the old quiet ones are hot young stars, blue, white, and fierce, and though they are rare, they are the brightest points in our night. They are the reason the sky has that cold sparkle. Now take all of that away. IC 1101 is an elliptical, which means it has no disk. Its stars do not circle together in a common plane the way ours do. They ride their own tilted orbits, crossing in every direction at once, more like bees swarming a hive than horses running a track. That swarming is not random chance. It is the fossil of how the galaxy was built, out of countless collisions that scrambled every orderly motion into this churning cloud. And because there is no disk, there would be no glowing river overhead. The starlight would spread evenly across the whole sky, brightening smoothly toward the galaxy's center, and thinning toward the dark in every direction. No band, no structure, a graded glow. Then there is the color, and here the age of the place shows itself. IC 1101 stopped making new stars a very long time ago. The fierce blue stars that light our nights burn through their fuel in only a few million years and then die, which on the cosmic clock is almost instant. In a galaxy that has not made a fresh star in billions of years, every one of those blue stars is long gone. What remains are the slow burners, the red and orange and yellow stars that live for many billions of years, and the swollen aging giants the old stars become near the end. We are not guessing at this. The galaxy's spectrum, the breakdown of its light by color, is dominated by exactly those cool old stars and carries none of the signatures hot young ones would leave. So the sky over IC 1101 would not sparkle white and blue. It would glow in warm amber and deep red, one autumn-colored light filling the whole dome. The bright street lamps have all burned out. What is left is the steady shine of the embers. That warmth would not mean the sky was dim, and here the scale turns sharp. Near the sun, stars are spread thin. Our nearest neighbor sits more than 4 light-years off, a gap so wide that the fastest craft we have ever launched would need tens of thousands of years to cross it. Near the heart of a giant elliptical, stars are packed hundreds of times more tightly. A world there might have neighboring stars a fraction of a light-year away, close enough to burn like distant cities rather than faint pinpricks. The night could hold not a couple of thousand stars, but a vast crowd of them, thousands upon thousands, every one of them old, every one warm-colored, a sky far brighter and far redder than any Earth has ever known. And yet, for all that crowding, it would be among the quietest skies imaginable. Our sky is a work in progress. Somewhere in it, stars are being born inside glowing clouds, and now and then a massive young star ends in a supernova bright enough to outshine everything near it for weeks. None of that happens here. No new stars. No clouds lit from within. No young suns flaring and dying. The last great wave of star formation in a galaxy like this finished billions of years ago, and it has been quietly reddening ever since. The sky over IC 1101 is a finished thing, an aging gallery where nothing new is hung, only the slow fading of what already hangs there. A watcher could stare for 10,000 generations and see essentially the same sky their earliest ancestors saw. Nothing of consequence would change. Look past the stars, and the strangeness only widens. A sky like ours ends at the edge of the Milky Way, past which lies mostly darkness sprinkled with a few faint smudges of distant galaxies. But IC 1101 sits in the middle of a cluster of hundreds of them. From inside, The night would carry more than its own stars. There would be the soft, diffuse glow of the intracluster light, those homeless stars drifting through the whole cluster, lending the dark a faint and permanent haze, and scattered out beyond. The other galaxies of Abell 2029 would hang as dim ovals and patches, near enough to notice, too far to resolve into stars. I did not expect the view from inside to fail in the same way it fails from out here. But it does. If you stood within IC 1101 and tried to find where the galaxy ended, you could not. The stars around you would just thin out as you looked outward, dissolving into the cluster's glow with no line, no wall, no last star marking a border. The same thing that defeats us from 1 billion light-years away would defeat someone standing right inside it. The edge is not hidden by distance. It is not there to be found from any vantage point at all. That is what an old giant elliptical really is. Not a monster in the sense of something fierce and active, but a monster in the sense of something vast and finished, a place where the violence is long over and only the embers are left, glowing warm and slow across a sky with no clear end. From outside it is a faint smudge 1 billion light-years away. From inside it would be a warm, crowded, motionless night. Both are true at once, and neither one tells you how large it is. If the galaxy has no edge from the outside, and no edge from the inside, how did anyone ever put a number on it at all? I used to think size was the simplest thing you could ask about an object. How big is it? You lay down a ruler, you read off a number, and the number belongs to the thing, not to you. Measuring IC 1101 cured me of that. Its size turns out to be one of those rare quantities where the answer is partly made by the person asking, and only partly found in the object itself. Start with the shape of its light. The brightness of an elliptical galaxy does not hold steady and then stop. It follows a smooth curve, blazing at the center and falling away outward. And that curve has a strange mathematical property that astronomers have leaned on for the better part of a century. It never reaches zero. It approaches the dark forever, fainter and fainter at every step outward, without there ever being a final point where the light becomes nothing. And yet, if you add up all the light along that endless curve, the total comes out finite, a glow that extends without limit, holding only a limited amount of light. The galaxy is, in the strict sense, infinite in reach and finite in substance at the same time. That single fact is the root of everything. A thing whose light never truly ends has no true outer radius, so every size we quote for it is a cut we impose, not a border the galaxy owns. Astronomers make the cut by drawing contours, lines connecting points of equal brightness. The way a map draws lines connecting points of equal height. The galaxy's size is simply whichever contour you choose to stop at. Pick a brighter contour, get a smaller galaxy. Pick a fainter one, get a larger one. There is no contour the galaxy points to and calls its own. You meet the same problem trying to say where a mountain ends. The peak is clear, the steep flanks are clear, but near the bottom, the slope eases so gently into the plain that no single step marks where mountain becomes ground. You define the base by some chosen grade, and your answer is partly about the mountain and partly about your choice. For most galaxies, this barely matters, because their light drops off so steeply that sliding the contour a little changes the size only a little. IC 1101 is the opposite case. Its light falls away so slowly that sliding the contour moves its edge by millions of light-years. The gentleness of that slope is exactly what makes the number impossible to pin. Now the part that genuinely turned the question inside out for me. What sets the faintest contour we can even reach is not a property of IC 1101. It is the brightness of our own sky. The night is not perfectly black. The air above a telescope glows faintly on its own. Dust within our solar system scatters sunlight across the whole sky, and the combined light of countless unresolved stars adds a dim floor of brightness everywhere we look. The outer glow of IC 1101 drops below that floor long before it reaches zero, and once it sinks under the brightness of our own sky, we simply cannot follow it any further. So the measured edge of a galaxy a billion light-years away is set, in part, by the glow of the air a few kilometers above the dome. Move the telescope to a darker site, or above the atmosphere entirely, and the galaxy grows, because you can chase its light a little deeper before losing it. Two observers under two different skies do not measure two different numbers for the same edge. They measure two different edges. The boundary lives in the meeting of the object and the observer, not in the object alone. Distance plays the same trick, and this one is built into the universe. Because space has expanded while the light traveled, the surface brightness of a distant galaxy is dimmed beyond the simple fall-off of distance, fading by a further share that grows with redshift. At IC 1101's distance, that dimming runs to roughly a third of its brightness, enough to pull its faint outskirts down below detection sooner than they would for a nearer twin. So a galaxy's apparent edge creeps inward the farther away it sits, not because the galaxy is smaller, but because expansion has thinned its outer light past what we can catch. The same object placed closer would look larger. Its size shrinks with our distance from it. When astronomers traced IC 1101's glow down to an extraordinarily faint contour far below the level most galaxies are measured to, it stretched close to 6 million light-years. The measurement was careful, and the number is real. What it never carries, when repeated, is the contour it was measured at, and the sky it was measured against, and the dimming it was measured through. Instead of chasing the vanishing edge, you can ask a question with no edge in it at all. Find the radius that contains half of the galaxy's total light, the half-light radius, and report that. It does not depend on where you stop, because half the light is half the light, no matter how faint the outskirts run. Measured that way, IC 1101's main body spans on the order of hundreds of thousands of light-years, several times the width of the Milky Way, far short of 6 million, still vast beyond anything ordinary. That is the number that holds still, and it is the one worth trusting. But even the honest number cannot escape the deepest problem. The faint light that inflates the size into the millions is not cleanly the galaxies at all. It is the outer envelope merging into the intracluster light, the stars stripped from devoured galaxies and now drifting through all of Abell 2029. There is no contour, no color shift, no change in how the stars move that marks a clean handoff from galaxy to cluster. The one fades into the other with no seam. So, tracing IC 1101 out to 6 million light-years does not measure a galaxy that happens to be enormous. It measures the place where a galaxy stops being a separate thing and becomes the bright floor of its cluster, and then calls the whole blend by the galaxy's name. This is what the measurement taught me, and it is stranger than any single number. Size is not always a property a thing simply has. Sometimes it is a relationship we complete. The galaxy is entirely real. Its light, its stars, its mass are all real. But its edge is something we author by choosing a contour, under a particular sky, across an expanding distance, through a haze of borrowed stars. We did not find the boundary of IC 1101. We drew one, and then read our own line back as though the universe had written it there. The unsettling thing about its scale was never that the number is so large. It is that the number describes a border that does not exist until we invent it. Which leaves the question underneath all of this. A smooth, edgeless, structureless swarm blending into the light of an entire cluster is not how galaxies are born. They are born with order, with disks and arms and clean rotation. For IC 1101 to have lost every trace of that, the order had to be destroyed, and destroyed again and again. What does it take to grind dozens of organized galaxies into a single shape with no structure and no edge left at all? There is a temptation to call IC 1101 a graveyard, a heap of beautiful galaxies ground into a shapeless mound, and I want to resist it because it gets the physics backward. The graceful spiral was never the natural state. The shapeless mound is. The real puzzle is not how the galaxies lost their order. It is how they ever held such order in the first place. Look at a spiral galaxy, and what you are seeing is coordination. Hundreds of billions of stars, all circling the same way, in nearly the same plane, like one enormous wheel turning in step. The arms are not solid objects, but patterns moving through that wheel, waves where stars crowd together for a while and then drift apart again. The entire graceful shape rests on coherent motion, on the stars agreeing to turn together, break the agreement, and the shape has nothing left to stand on. It was never built of matter so much as of cooperation. So picture two such wheels falling toward each other. The first thing to set straight is that they do not crash the way the word collision suggests. Stars are absurdly far apart compared to their size. Shrink the sun to a grain of sand, and its nearest neighbor would be another grain about 30 kilometers away. Two galaxies can pass clean through each other, and almost no two stars ever touch. The destruction is not done by impact, it is done by gravity, and gravity needs no contact at all. As the two galaxies interpenetrate, the gravitational field of the whole system heaves and lurches, and every star feels the ground shift beneath it. Their careful shared rotation is torn apart, each star wrenched onto a new path by the changing pull of everything around it. The ordered turning, all that motion in step, is converted into random motion, stars flung onto tilted crossing orbits with no common direction left among them. Astronomers call this violent relaxation, and it is fast, finishing in a few 100 million years, which for a galaxy is a single hard blow. When it ends, the disk is not hidden. It is gone. The coherence that made it a disk has been scrambled into noise. The orbital spin the two galaxies carried in does not simply vanish, either. Much of it is flung outward, into long tidal tails of stars streaming off into the dark and into the swelling outer halo. Some of those streamers fall back, some never do. The center, meanwhile, is left turning barely at all. A spiral holds its shape through rotation like a spinning plate. What rises from a major merger holds its shape a different way, through the sheer random speeds of its stars, each tracing its own steep orbit, the way molecules in a hot gas press outward in every direction at once. The smoothness is not wreckage, it is equilibrium. A swarm of stars on random orbits, left to itself, settles into a smooth, featureless cloud, because smooth and featureless is simply what maximum disorder looks like. The galaxy fell into the shape that disorder always prefers. The change is permanent, and the reason is worth following carefully. Drop a bead of ink into a glass of water, and it spreads, thread by thread, until the whole glass is faintly gray. No amount of stirring will ever gather it back into a single drop. The stars of a merged galaxy do the same thing in their orbits. They begin in a tidy arrangement, then spread through every path the new galaxy allows, until the memory of the original disk is smeared evenly across the entire swarm. The information is not destroyed, exactly. It is diluted past any hope of recovery, scattered so finely through the motion of 1 trillion stars that no force could ever pull it back together. This is why there is no such thing as unmerging two galaxies. The arms do not return. The disk does not reform. Order, spent this way, stays spent. Set that against IC 1101, because what happened to it was not one collision but a long line of them. Dozens of galaxies fell in over billions of years, and very likely many more, each a spiral or a smaller elliptical carrying its own order, and each had that order ground away and folded into the growing swarm. There is a useful distinction here. The early collisions between galaxies of comparable size are what shattered the disks and built the great elliptical body. The countless smaller ones that came later, little galaxies swallowed whole, mostly piled onto the outer halo, padding it wider and fainter with every meal. That layering is exactly why the outskirts run so far and end so softly. The edge is unfindable because it was assembled, scrap by scrap, from the torn-off remains of everything that ever fell in. Turn the graveyard image over, and it inverts. A graveyard keeps its dead apart, each in a marked plot, named and separate. IC 1101 is the opposite of that. Its galaxies are not buried side by side. They have been stirred into one another until identity itself is gone, until there is no first galaxy and no last, only one continuous swarm wearing the blended remains of dozens. And the featureless result is not a deviation, it is the destination. Given enough collisions and enough time, this is what gravity does to galaxies. It drives them toward the smooth, the random, the structureless. The delicate spiral, the thing we find beautiful, is the fragile and temporary arrangement. The shapeless giant is what the universe settles into once the stirring is finished. What I keep circling back to is that IC 1101 is not a ruin of something that should have lasted. It is closer to a finished state, an object that has already arrived where slower galaxies are still headed. Our own ordered Milky Way is the unusual thing, the brief lucky stretch of coherence. This giant has simply run further down the road that order always travels in the end. And yet, through all that grinding, one thing survives untouched. Gravity can scramble the orbits and erase the shape the stars were born into, but it cannot reach inside the stars themselves. Each one keeps burning on its own private clock, indifferent to the chaos that rearranged it. Those clocks have been running a very long time now, and their light still carries a faithful record of how long, written in a color that works like a kind of timestamp on the whole galaxy. If the shape of a galaxy can be erased so completely, what is it that the color of its light still remembers? The color survived because color is the one thing a star cannot fake. A star's color is set by the temperature of its surface, and that temperature is set, above everything else, by its mass. The heaviest stars burn blue-white and ferociously hot. The lightest burn dim and red. But mass also decides how long a star lives, and it decides it backward from what you would guess. The massive blue stars, holding the most fuel, spend it so recklessly that they die young. The small red ones sip theirs and last almost forever. So a star's color is quietly a clock. It tells you not only how hot the star is, but how much time it was given, and how much of that time it has already spent. The numbers are lopsided past intuition. The sun will shine for roughly 10 billion years. The brightest blue stars burn themselves out in only a few million, gone in less than 1,000th of the sun's lifetime. At the far end, the smallest red stars can glow steadily for trillions of years, longer than the universe has yet existed. Now, take a whole population of stars born together, the way a galaxy makes them. At first, the mix blazes blue, because the hot, massive stars are present and they drown out everything else, but they are also the first to go. As the population ages, the blue stars wink out one mass at a time, heaviest first, and the galaxy's overall color slides steadily toward red. The brightest stars still alive at any moment mark how much time has passed, like the hand of a clock built from dying stars. Astronomers read that hand. The color of a galaxy is, in part, its age told in light. Point that reading at IC 1101, and the answer comes back stark. Its light is deep, gold and red, with no real blue left in it at all. Every hot, massive star it ever made died billions of years ago, and none have been made since. What shines now are the patient low-mass stars and the swollen red giants that aging stars become near the end, a whole galaxy lit by embers. And the redness means more than old. It means stopped. A galaxy still making stars keeps replacing its blue ones, keeps a fresh sparkle no matter how ancient the rest may be. IC 1101 has none of that. It ran out of the cold gas that stars are built from, and without that gas, it cannot make a single new one. The phrase astronomers use is red and dead. The gold is the color of a galaxy that has lost the ability to make anything new, shining on with only what it built long ago. Color is not only a clock, it is also a chemistry. Stars formed from gas already rich in heavy elements burn a little cooler and redder than stars formed from near pure hydrogen, because those elements blanket a star's surface and trap its light. And IC 1101 is rich in heavy elements, which is the paradox. It is old, yet chemically enriched, when enrichment normally takes many generations of stars to build up. The answer is in how it formed. Its stars were made early, but made fast and furiously. Generation crowded upon generation in a short, intense beginning, each one seasoning the gas for the next before the supply was spent or driven out. The galaxy enriched itself at tremendous speed, then quit. So its redness is two things braided together. Part of it is age. Part is the metal richness of a fast, early, self-enriching burst. There is a counterintuitive pattern underneath this, one that startled astronomers when they first untangled it. You would expect the largest galaxies to take the longest to build. The opposite is true. The most massive galaxies form their stars earliest and fastest, then shut down first, while smaller galaxies dawdled along making stars for billions of years more. The giants were not slow to grow. They were the first to finish and the first to die. Color alone can fool you, though, and astronomers have known it for a long time. Through a single broad filter, an old population poor in metals can mimic the exact shade of a younger population rich in them. The color by itself is ambiguous, so no one rests the conclusion on color alone. They spread the light into a full spectrum and read the narrow dark lines stamped across it by individual elements, lines whose strengths pull the effect of age apart from the effect of chemistry. We do not glance at the gold and guess. We read the fine print written through it. Once you can read that fine print, the color becomes more than a clock. It becomes a fossil record. The full spectrum of an old galaxy carries the trace of its entire history of making stars, when they were born, how quickly, and when the making stopped. For IC 1101, that record points to a beginning more than 10 billion years ago. In the young universe, a furious early bloom that built nearly the whole galaxy in a relatively short span, and then ended. Everything since has been one long, slow reddening. We are looking at the afterglow of an event that finished before the sun and the earth existed. It still stops me that a color can carry a date. From a billion light-years away, through all the softness of distance and edge and definition, this one thing comes through hard and clear. We can stand here and say, with real confidence, roughly when this galaxy lived and roughly when it died. The light that lost all track of where the galaxy ends has kept perfect track of when it ended. And that ending runs one way only. Bank of fire and the coals glow orange, then deep red, then dark, cooling along a path they can never climb back up without fresh fuel. The color of IC 1101 moves the same direction for the same reason. With no new gas, the surviving stars only age, the population only reddens, and the gold deepens toward darker red across the eons ahead. There is no shade it can return to, no way to flush itself blue again. Short of a river of cold gas, it has no means to find. The clock turns one way. The embers do not reignite. So, The stars hold the memory of when. What they do not explain is how they move now, locked in this structureless swarm with no disk to ride and no shared direction to follow. A galaxy that lost its rotation should, by every simple expectation, fall inward and collapse on itself. IC 1101 does not. It holds itself open, vast and steady, against its own staggering weight. What keeps a trillion stars with no common direction from simply falling into the center? The question sounds like it should have an easy answer, and it does not. A spinning galaxy stays open the way a thrown ball stays aloft while it moves, held by its rotation. Take the rotation away, as the mergers did, and the plain expectation is collapse. A trillion stars falling straight inward into one catastrophic pileup. IC 1101 has had billions of years to do exactly that. It has not drifted an inch toward it. The thing holding it open is the same thing that should be pulling it shut. It is held up by motion, only not the kind we are used to. Think of an ordinary gas, the air in front of you. It does not collapse into a puddle on the floor, though gravity pulls on every molecule, because the molecules are moving fast in every direction, and their motion pushes outward as hard as gravity pulls in. We call that pressure. A giant elliptical works the same way, with stars standing in for molecules. Each star truly is falling toward the center, but almost none of them are aimed at it. Each carries sideways speed, so instead of striking the middle it sweeps past, swings out the far side, slows, and falls back in. An orbit is a fall that keeps missing. IC 1101 is a trillion of those falls, every one perpetually missing the center, all of them together averaging into the smooth, steady shape we see. The galaxy is not resting. It is a storm of near misses held in balance. How fast the stars must move depends on how deep the well is, and this well is deep. The stars of IC 1101 race along at several hundred kilometers every second, fast enough to travel from the Earth to the Moon in about 20 minutes. And yet the galaxy is so vast that a single star, at that speed, needs a few 100 million years just to cross it once, side to side. So from a billion light-years away, IC 1101 looks utterly frozen, a still gold cloud unchanged in every image we have ever taken. The stillness is a lie of scale. Every star in it moves with ferocious speed. The galaxy is simply so enormous that even that speed reads, from here, as perfect rest. Now a fact that overturns the easy picture of stars jostling like a swarm of bees. They almost never touch, and they almost never even come near. Recall the grain of sand and its neighbor 30 kilometers off. At those separations, the chance of two stars colliding or even passing close enough to fling each other onto a new path is vanishingly small. The time it would take for these gentle star-to-star tugs to noticeably rearrange the swarm is not millions of years, and not billions. It is millions of times longer than the universe has so far existed. So the stars of IC 1101 are not constantly bumping and reshuffling. They are effectively collisionless, each one gliding along its own orbit nearly untouched by any single neighbor, feeling only the smooth combined gravity of the whole. Which raises a real puzzle. If the stars barely interact, how did the arrangement ever get so smooth? The answer reaches back to the violence that made the galaxy. The smoothing did not happen slowly, star by star. It happened all at once, during the mergers, when the gravitational field of the whole system was heaving and the orbits were scrambled in a single fast convulsion. After that, the stirring stopped, and the swarm froze into the pattern the chaos had handed it. Each star out there is still riding, more or less, the orbit it was thrown onto billions of years ago. The galaxy was relaxed once, hard and fast, and has been coasting on that one event ever since. Here, a gas of stars and a gas of air part ways, and the difference is everything. Real gas cools. Its molecules collide endlessly, and in colliding they shed energy as light and heat, and as the gas cools it loses pressure and sinks and collapses. That is how stars themselves are born, from gas that cooled and fell. A gas of stars cannot do this. With no real collisions, it has no way to bleed off its motion, no way to cool, no way to lose the pressure holding it open. The random speeds that keep IC 1101 spread wide can never be radiated away. So the galaxy is not only dead in the sense of making no new stars, it is frozen in the sense of being unable to change its own shape. It cannot cool, cannot shrink, cannot fall in on itself. It is a steady state able to outlast nearly anything, holding smooth and open for spans that dwarf the present age of the universe. Gravity hides one last strangeness in here, and it owns this one alone. In everything else, take energy out of a thing, and it slows and cools. A self-gravitating swarm does the reverse. Pull energy out of it, and it grows hotter. A star that loses energy and sinks toward the center does not slow as it falls. It speeds up, the way anything falling speeds up, ending faster than it began. So these systems carry a backward thermodynamics, where losing energy raises the temperature instead of lowering it. It means a galaxy like this never reaches a final, perfect rest. There is always a slow inward creep at the core and a slow outward spread at the fringe, gravity quietly shuffling itself across timescales so long they barely register. It is the strangest balance in nature, one that holds for eons while never quite being finished. The hardest thing for me to keep steady in my mind is that none of this is still. The smooth gold shape, the thing that looks more like a painting than a place, is a trillion stars in perpetual fall, each one racing, each one missing the center, all of them summing to a calm that exists only because we are too far away and too short-lived to catch the motion. The piece of IC 1101 is real, and it is also an artifact of our distance. Up close, it would be a maelstrom. From here, it is the most restful thing in the sky. But the scrambling that froze this swarm into place did not manage to keep every star. Some were flung too hard. When the orbits were thrown during those mergers, a share of the stars were handed more speed than the galaxy could hold, and they were cast out past its fringe, into the cluster, set adrift forever between the galaxies with no home left to fall back to. Where do the stars go when a galaxy throws them away? The surprising part of the answer is that the star never actually gets away. A galaxy can throw a star clean past its own outskirts, fast enough that it will never fall back into the galaxy again. But the galaxy is not the deepest thing around. The cluster is. Beneath IC 1101 lies the vast gravitational well of Abell 2029. The dark matter halo that outweighs every galaxy in it many times over, reaching far wider and pulling far harder than any single galaxy ever could. So the cast-out star escapes its home only to be caught by something larger. It trades a small orbit around a galaxy for an enormous orbit around the whole cluster. It is free of its galaxy. It is not free at all. Do this to enough stars, across enough collisions, over billions of years, and you build something with a name. Astronomers call it the intracluster light, the faint, diffuse glow of stars that belong to no galaxy, scattered through the empty space between them, orbiting the cluster's center rather than any single home. It is not a small effect. In a cluster like this, the light from these homeless stars can add up to a sizable fraction of all the starlight present, tens of % of it, a glow as substantial as many of the galaxies it drifts among. We are talking about billions upon billions of stars with no galaxy at all. Picture it as an ocean rather than a crowd. If you stood among these stars, you would not notice any ocean. you would see only the sparsest sky imaginable, a star here, another impossibly far off there. The density is almost nothing. But the volume is staggering. Millions of light years across in every direction, and almost nothing spread through a volume that large still sums to billions. The intracluster light is faint everywhere, and immense in total. The way an ocean is mostly empty water and still holds more than anyone can count. And every one of those stars is a survivor of something destroyed. They were not born out here in the dark between galaxies. They were born inside galaxies, ordinary ones, and they were torn loose when those galaxies fell into the cluster and were pulled apart by the tides of all that gravity, stretched into long streams and finally scattered. The intracluster light is the dispersed remains of dead galaxies, their bodies shredded and spread so thin that nothing of the original shape survives, only the individual stars, still burning, drifting outward one by one. The ocean is made of ghosts. And this is what finally explains the missing edge we have circled since the beginning. The faint outer envelope of IC 1101 is not a separate thing from that ghost ocean. It is the dense inner part of the very same population, the stripped and scattered stars that have not yet drifted far from the center. Move outward from the bright core, and the stars thin smoothly, their orbits stretching wider and wider, from tightly bound to the galaxy, to loosely bound, to bound only to the cluster, with no point anywhere along the way where one kind becomes the other. The galaxy does not end, and the intracluster light begin. They are one continuous sheet of stars, fading from a galaxy into a cluster across millions of light years. That is why no contour can mark the edge. There is no edge to mark. There is only a population thinning out, the same stars, all the way down. These ghosts keep records, and that turns the ocean into an archive. A star carries the chemistry of the galaxy it was born in, locked into its light, and stars torn from the same galaxy tend to drift together for a long time before fully dispersing, forming faint streams and clumps within the diffuse glow. In nearby clusters we can still see these streams directly, faint arcs and shells of light looped through the space between galaxies, the visible scars of recent meals. By mapping the chemistry of the intracluster light and the streams still tangled through it, astronomers can read which galaxies were eaten, how large they were, and roughly when they were torn apart. The cluster's whole long history of cannibalism is written into the scattered light of its victims. The ghosts carry their own death certificates, and we have learned to read them. There is one more thing these stars quietly do. Because they are bound to the whole cluster rather than to any galaxy, they spread themselves through the cluster's overall gravity, the dark matter we cannot see directly. Their distribution roughly follows the shape of that invisible halo. So the ghost light is one of the few visible tracers we have of the dark scaffolding holding everything together. The dead stars, drifting with nothing to belong to, end up sketching the outline of the largest unseen structure in the cluster, the visible faintly mapping the invisible. Of everything out here, the intracluster stars are the ones I find hardest to file away. Ask which galaxy one of them belongs to, and there is no honest answer, because it belongs to none. Its galaxy is gone, torn apart ages ago, and the star simply continued, unchanged inside, indifferent to the loss of the thing it was once part of. The longer I look at that, the less sure I am the question even means anything. We assumed a star is always part of a galaxy, the way we assumed a galaxy has an edge. The ghost ocean breaks the second assumption the way IC 1101 broke the first. Out here, belonging to a galaxy is simply not a property a star is required to have. Think back to that crowded warm sky we imagined at the center of IC 1101, thousands of old stars burning close together. A planet orbiting one of these intracluster ghosts would have the opposite sky, and the loneliest one possible. Almost no nearby stars at all. No band of a home galaxy overhead, because there is no home galaxy. Only the dark, and scattered across it the faint, distant ovals of galaxies it will never reach, and the dim wash of all the other ghosts too far to make out. A sun in the middle of nothing, under a black and nearly empty sky, falling along an orbit billions of years long around a center it cannot see. We have followed the stars thrown outward, all the way to the edge of everything. Now turn and go the other way, inward, past the bright core, down toward the single point that all of this is ultimately falling around, because at the very bottom of the well sits something that anchors the whole churning swarm, a heart heavy beyond easy belief. What sits at the center of a galaxy that swallowed 100 others? After all that softness, all those fading edges and homeless stars, the center of IC 1101 does something the rest of it never does. It draws a line that cannot be crossed, the sharpest and most absolute boundary anywhere in nature. At the very heart of the galaxy, with no edge, sits the one object in the universe that has a perfect one. It is a black hole, and not an ordinary one. The black hole at the core of our own Milky Way weighs about 4 million times the mass of the Sun, which already sounds beyond imagining. The one inside IC 1101 is estimated at something on the order of tens of billions of solar masses, by some measures among the most massive black holes ever identified. That number is far from settled. We cannot weigh it directly. The figure comes from indirect methods, from how fast things move near the center, and from patterns that tie black holes to the galaxies around them. And at this extreme, those methods carry wide uncertainty. What is not in doubt is the rough class of the thing. It is one of the heaviest single objects known to exist. A black hole's defining feature is its event horizon, the surface within which nothing can ever return. Not matter, not light, not information of any kind. Unlike a galaxy's fuzzy outskirts, this boundary is exact. Its size is fixed precisely by the black hole's mass, a clean mathematical sphere with a definite radius, the most well-defined edge physics knows of. For a black hole this massive, that horizon could be wider than our entire solar system, a sphere several light days across, and yet, set against the galaxy it sits in, it is almost nothing. If the galaxy were a city, the horizon would be a single grain of sand near its center. The galaxy spans millions of light years and refuses to end. Its heart is a perfect sphere a few light days wide. The largest fuzzy thing we know of guards the sharpest small edge there is. It is tempting to picture this black hole as the thing holding everything together, the anchor of the whole cluster. It is not, and the gap is not close. The cluster is bound by its dark matter, a mass on the order of 100,000 billion suns or more, and even tens of billions of solar masses is some 10,000 times too small to hold that together. The black hole's real reach is far more modest. It dominates only the innermost region of the galaxy, a zone perhaps tens to a few hundred light years across, where its pull outweighs the combined pull of all the surrounding stars. Astronomers call that the sphere of influence. Beyond it, out through the vast body of the galaxy, the stars themselves run things, and beyond them, the dark matter. The black hole is the heart, not the skeleton. It rules a small throne room at the very center, not the kingdom. There is something stranger here than the mass. Across many galaxies, the mass of the central black hole tracks the random speeds of the stars far out in the galaxy, the same motions that hold the whole swarm open. The heavier the black hole, the faster those distant stars move, in a tight and reliable relationship. The trouble is that those stars sit millions of times farther from the black hole than its gravity can reach. They do not feel it. They cannot feel it. Its pull is utterly negligible out where they orbit. So how does a black hole the size of a grain of sand in this scaled-down city end up with a mass that matches the motion of stars at the city's far edges? Stars it has no direct grip on at all. The pinprick somehow knows the giant. That connection is real, measured again and again, and we still do not fully understand why it holds. It is one of the real open puzzles about how galaxies and their black holes grew up together. Part of the answer is that the black hole grew the same way the galaxy did, by eating. Every galaxy IC 1101 swallowed carried its own central black hole inward with it. As the devoured galaxy sank toward the center and was torn apart, its black hole kept sinking, dragged down by the same friction that pulls everything to the bottom of the well, until it reached the middle and, in time, merged with the black hole already waiting there. So this ultramassive heart is not one black hole that simply grew. It is the merged sum of the central black holes of all the galaxies that ever fell in, the fused hearts of dozens of dead galaxies combined into a single deeper dark. The stars of the eaten galaxies became the ghost ocean drifting outward. Their hearts went the other way, falling inward, joining into the one heart at the bottom. The galaxy gathered its victims' bodies into its halo and their hearts into its core. It is mostly quiet now. A black hole only blazes while it feeds. When gas spirals in and heats to a ferocious glow before crossing the horizon, and IC 1101 ran out of cold gas long ago, with nothing left to swallow, the heart has gone dark and still. But it was not always silent, and its loud past may have shaped everything around it. When a black hole like this feeds, it can pour out tremendous energy, enough to heat and drive away the very gas a galaxy needs to build new stars. The leading explanation for why galaxies like this one turn red and dead points partly back here, to the black hole. In its active youth, it may have helped shut off the star formation that fed it, blowing away the fuel and ending the galaxy's power to make anything new. If that is right, the heart did not merely sit at the center. It helped kill the galaxy it lives in, then fell quiet over the body. What I cannot get past, at this one spot, is the reversal. Everything else about IC 1101 dissolves the idea of a boundary. The stars trail off with no clear last star. The galaxy has no clear edge. A star out in the dark need belong to no galaxy at all. The whole object is a long lesson in how rarely the universe draws a hard line. And then, at the exact center, it draws the hardest line there is, a surface so absolute that crossing it is the most irreversible act physics permits. The edgeless giant keeps, at its core, the one true edge in all of nature. The black hole grew by eating other hearts. The galaxy grew by eating whole galaxies. We have spoken of that hunger from a distance, named it cannibalism, watched its leftovers drift in the ghost ocean and settle into the core. But we have not yet watched it happen. What does it actually look like for one galaxy to eat another? Forget the word swallow, because it carries the wrong speed. When one galaxy eats another, nothing about it is quick. There is no bite, no gulp, no moment of impact. There is a slow gravitational dismantling that unfolds across hundreds of millions of years, often more than 1 billion, so gradual that at any single instant it would look like perfect stillness. It is among the most violent things the universe does, and among the slowest. The two facts do not cancel each other. Together they are the whole character of it. It begins with a smaller galaxy wandering too close. Drawn by the deep well beneath IC 1101, it falls inward, but it does not fall in a straight line and strike the center. It loops past, swings wide, comes back. Each pass a little tighter than the one before, spiraling slowly down. What tightens the spiral is a drag with no surface to it. As the small galaxy plows through the stars and dark matter of the giant, Its gravity pulls that material into a faint wake behind it, a trailing overdensity, like the wake behind a boat made of gravity instead of water. That wake then pulls back on the galaxy that raised it, stealing its orbital energy bit by bit. The victim is slowed by the very disturbance it stirs up, and a slowed orbit is a sinking orbit. Astronomers call this dynamical friction, and it is the engine that drags everything down to the bottom. As the small galaxy sinks closer, a second force takes hold and begins taking it apart. Gravity does not pull equally on the near side and the far side of the victim. The side facing IC 1101 is pulled harder than the side facing away, and that difference, stretched across the whole galaxy, draws it apart along the line toward the center. The near stars are pulled ahead, the far stars left lagging, and the galaxy is drawn out into long streamers, leading and trailing, unwinding like thread off a spool. No star is ever struck in this. Recall how far apart stars are. The dismantling is done entirely by the difference in pull from one edge of the victim to the other, a purely gravitational shearing that stretches a galaxy into ribbons without a single collision. Then those ribbons are folded in. The stretched streams wrap around the giant and spread slowly through its swarm, their orderly motion scrambling into the random orbits of everything already there, the same phase mixing that smooths any merger. The victim's outer stars, flung wide, join the ghost ocean drifting through the cluster. Its inner stars sink deeper. Its dense core, bound more tightly than the rest, survives the longest, sometimes lasting as a distinct knot, still spiraling inward long after the outer galaxy has dissolved, and its central black hole keeps falling, all the way down, until it merges with the heart already waiting there. Everything we traced in the last several chapters is only the aftermath of this one process, seen at different distances from the center. The ghost ocean, the edgeless envelope, the fused heart, all of it is what a swallowed galaxy becomes once it has been taken apart and sorted by how far each piece ends up from the middle. And it is almost entirely one-sided. When two galaxies of similar size merge, both are destroyed, and something new rises from the wreckage, the way the great elliptical body first formed, but a giant eating something far smaller barely notices. IC 1101 is so much larger than the galaxies it consumes that each meal scarcely alters its shape. The victim is unmade completely. The giant simply grows a little heavier, its halo a little wider, and turns toward the next. This is accretion more than collision, a large thing quietly adding small things to itself, over and over, for billions of years. The word cannibalism makes this sound like an act of will, and that may be the most misleading thing about it. There is no aggressor here. IC 1101 does nothing. It does not reach out, does not hunt, does not pull anything toward itself on purpose. It only sits at the bottom of the deepest well around, being massive, exactly as it would if nothing ever came near. Everything else is done by the victims and by geometry. The small galaxies fall in on their own, pulled by a gravity that asks for no intention. The tides that tear them apart are nothing more than the shape of that gravity stretched across a little distance. The most voracious object in this whole region of the universe turns out to be the most passive thing in it. It eats the way a valley floor collects rain, not by wanting to, by being the lowest place there is. That is why this is not really an event in the galaxy's life. It is a condition of the place. As long as anything still drifts within reach of the well, on an orbit slowly decaying through friction, it will eventually be drawn down and taken apart. The eating is continuous, glacial, effectively endless, pausing only when nothing close enough remains to fall. IC 1101 did not have a feeding period that ended. It has a location, and the location feeds, slowly, for as long as the cluster keeps handing it something to consume. We are not guessing that this happens. We catch it mid-act. Around giant central galaxies like this one, astronomers find the signatures everywhere. Faint shells and loops of stars wrapped around the core, long tidal streams still hanging in the halo, and sometimes more than one bright nucleus inside a single galaxy, the surviving cores of meals not yet finished, still sinking toward the center. IC 1101 itself shows signs of this ongoing digestion. The leftover structure of galaxies caught partway through being absorbed. We are seeing a billion-year process frozen at one instant, the way a single photograph catches a falling drop in midair. A meal here lasts longer than the entire stretch from the first complex animals to now. During one such merger, a star in the doomed galaxy completes only a handful of orbits before its home is gone. From inside that galaxy, there would be no catastrophe to witness, nothing to run from. Across millions of years, the familiar sky would slowly stretch and distort, the home galaxy quietly unwinding into streams too gradual for any creature to feel within a lifetime or 1,000 lifetimes. The destruction would arrive disguised as stillness, a violence so slow it would pass for peace. For all that consuming, though, something is missing from the result. When galaxies collide, the natural expectation is fireworks, bursts of brilliant new stars flaring up from the shock of all that gas slamming together. IC 1101 has eaten dozens of galaxies and produced almost none of that. The greatest feast in the region threw no party at all. Why does swallowing 100 galaxies make a giant that cannot light a single new star? The missing fireworks have a one-word cause: gas. New stars are born only from cold, dense clouds of gas collapsing under their own weight, and a galaxy with no such gas cannot light a single new star, no matter how large it grows. IC 1101 grows constantly. It simply grows by eating things that bring no gas with them. To see why that matters, set two kinds of collisions side by side. When two gas-rich galaxies merge, two young spirals still full of cold clouds, the collision drives all that gas crashing toward the center, compressing it, shocking it, and igniting a furious burst of new star formation. The sky fills with brilliant young blue stars. This is a wet merger, and it is where the fireworks live. A dry merger is the opposite. When the galaxies coming together have already used up or lost their gas, there is nothing to compress and nothing to ignite. The two old populations pass through each other and settle together, old stars added to old stars, and not one new star is lit. IC 1101 grows almost entirely through dry mergers. It is not joining living galaxies. It is collecting dead ones. And the cluster itself does the killing, before the giant is ever involved. A galaxy falling toward IC 1101 must first pass through the cluster's hot gas, that searing thin medium filling the whole volume. As the galaxy plows through it at hundreds of kilometers a second, that hot gas acts like a headwind, and the wind strips the galaxy's own cold gas right out of it, blowing away the fuel it would have needed to make new stars. Even galaxies that keep a little are choked another way, cut off from any fresh supply, surrounded only by gas too hot to fall in. They slowly burn through what they have and quietly go dark. So, by the time a galaxy reaches the giant at the bottom of the well, the cluster has usually killed it already. The cluster is a graveyard that does its work on the way down. IC 1101 assembles itself almost entirely from things that were dead on arrival. This produces a paradox that took me a while to fully take in. IC 1101 grows without renewing. Its mass climbs across billions of years, while its power to make anything new holds at zero. It becomes larger and deader at once by the very same process. Think back to the embers. Pour one bed of dying coals onto another, and you get a larger bed of dying coals, glowing a little broader. But you have not lit a new flame. You never could, that way. Combining old stars with old stars can only ever yield more old stars. The mass of IC 1101 is staggering because it has spent eons gathering the spent fuel of other galaxies. The very thing that made it the largest is the thing that guarantees it makes nothing new. There is a complication here, and it makes the story stranger rather than simpler. IC 1101 is not entirely without gas. The center of the cluster holds a great deal of it. The hot X-ray gas pooled in the deepest part of the well, and hot gas, left alone, should cool. As it cools, it should sink toward the center, grow dense, and begin forming stars, the very fuel the galaxy seems to lack. By the simplest calculation, the gas at the heart of a cluster like this should be cooling fast enough to build new stars at a tremendous rate, enough to set the giant blazing with fresh star formation. It does not. The expected new stars are almost entirely absent. For a long time, this was a real problem, a gap between what the physics predicted and what the sky actually showed. Something was keeping that gas from cooling. The something is the black hole, working not in some violent past, but quietly and continuously, right now. Even a starved black hole feeds a little, and when it does, it launches jets and blows great bubbles into the surrounding hot gas, pouring energy back into it, reheating whatever has begun to cool. The result is a slow balance. Gas tries to cool and sink. The black hole senses the inflow, stirs, and reheats it. The cooling stalls, the black hole quiets, and the cycle turns again, over and over. Across billions of years, it works like a thermostat, holding the cluster's core just hot enough that it can never quite collapse into new stars. So the galaxy is not merely dead from one ancient catastrophe. It is kept dead, gently, on an ongoing basis, by its own heart regulating the only fuel it has. The black hole does not roar. It tends, and what it tends is the galaxy's sterility. Every path back to life is closed, then. Fresh, cold gas from outside is stripped away before it can arrive. The hot gas already present is held too hot to use. And the mergers that grow the giant deliver nothing but more old stars. There is no door left open through which new star formation could return. The death of IC 1101 is not a stage it is moving through. It is a locked state, defended on every side by the same forces that built it. What changed how I think about IC 1101 was realizing the size and the death are not two separate facts, they are one fact. Everything we love about galaxies, the new stars, the blue light, the glowing nurseries, the slow turning cycle of birth, depends on gas that can cool and fall and collapse. IC 1101 grew large by precisely the process that strips that possibility away. It is not a living galaxy that happens to be enormous. It is enormous because it stopped being a place where things are born. The most massive galaxy we know became that way by becoming, completely and permanently, a place where nothing new can begin. Size and sterility are not in tension here. They are the same story, told once. So it grows on, sterile and steady, gathering the dead. But it cannot do this forever. A cluster holds only so many galaxies, and the giant has been eating them for most of the age of the universe. The supply that built it is running low. What happens to a thing that grows only by consuming when there is finally nothing left to consume? The question hides an assumption that somewhere there is a wall, a maximum size a galaxy is allowed to reach before something stops it. There is no such wall. Nothing in the physics of gravity caps how large a galaxy can grow. Pile on more mass, and it simply becomes a more massive galaxy, deeper well and all. So, if IC 1101 stops growing, and it will, the limit will not come from any ceiling on size. It will come from running out of things to eat. A galaxy that grows only by consuming is bound entirely to its food supply. IC 1101 cannot make new mass. It can only gather mass that already exists nearby and falls within its reach. And the cluster that feeds it, for all its hundreds of galaxies, holds only a finite number of them. There is a last galaxy. There is a bottom to the larder. The slowing has already been underway for a long time. The largest galaxies in a cluster sink toward the center fastest, because the heavier a galaxy is, the stronger the gravitational wake it drags behind it, and the harder that wake pulls it down. So the giant ate its biggest neighbors first, early, when the cluster was young and crowded. What remains now are the small galaxies and the distant ones, and those sink with extreme slowness. For a small galaxy on a wide orbit, the time it would take dynamical friction to drag it all the way to the center is not millions of years and not billions. It is far longer than the universe has yet existed. So most of what is left will essentially never arrive. The giant did the bulk of its growing in the first several billion years, and everything since has been a thinning trickle, each new meal smaller and slower than the one before. The growth does not strike a wall. It fades toward a limit it approaches but never quite reaches, the way a curve bends closer and closer to a line it never touches. Surely fresh galaxies could fall into the cluster from outside, new food arriving from the wider universe to refill the larder. For most of cosmic history, that is roughly what happened. Clusters grew by drawing in galaxies and smaller groups from their surroundings. But that door is closing, and what closes it is the expansion of the universe itself. Space is not only expanding, it is expanding faster and faster, and beyond a certain distance, everything is receding from the cluster more quickly than the cluster's gravity can ever pull it back. A galaxy cluster is the largest thing held together by its own gravity, and that is now close to a permanent boundary. The cluster will gather nothing more from beyond itself, because beyond itself, everything is being carried away. The larder is not only finite, it has been sealed. Nothing new will ever fall into Abell 2029 again. There was one last way to find fresh food, and expansion is closing that too. A cluster can sometimes collide with another cluster, and such a merger would deliver a whole new population of galaxies for the giant to eventually consume. But Abell 2029 is a relaxed, settled cluster, with no major collision in its recent past and no large neighbor on a converging course. And as expansion drives every bound structure deeper into isolation, these cluster-scale mergers grow rarer with time, until at last they become impossible, every surviving island of gravity left alone with whatever it managed to hold. The supply that built IC 1101 is not only running low, it is the last supply there will ever be. This is what gravitational saturation really means, and it is gentler and stranger than the word suggests. The giant does not strain against some maximum and stop. Gravity never gives out. The galaxy simply consumes the reachable galaxies, slows as the reachable ones grow scarce, and then waits, while the universe quietly removes any possibility of more. The limit is not written into IC 1101 at all. It is written into the orbits of what surrounds it, and into the expansion of the cosmos around that. A thing whose entire nature is to consume reaches its end, not by bursting, and not by collapsing, but by running out of others while the universe locks the door behind the last of them. What waits on the far side of that is a finished object. IC 1101 is approaching a final mass, a final size, a final arrangement that it will then simply hold. And recall what we learned about its insides. It cannot cool, it cannot collapse, it makes no new stars. Once the last reachable galaxy is absorbed, there will be nothing left to change it at all. The building of this giant which has taken most of the age of the universe, will turn out to have been the brief part. The being finished, the holding of that final shape in the dark, will last incomparably longer, stretching across spans beside which the whole history of its growth is a single opening moment. What strikes me is that its limit does not come from inside it at all. Almost everything we know is mid-process, still becoming, still pushed and pulled by what it might yet turn into. IC 1101 is one of the few things large enough and old enough to be nearly done, not because it wore itself out, but because the universe around it gently ran out of anything more to give. What that leaves behind is a kind of stillness, and not the kind you would expect. Not the stillness of rest, since every star still races, but the stillness of completion, of a thing that has done very nearly all the becoming it will ever do, and has begun the long settling into simply remaining. And yet, even as it nears that final size, a question hangs over the title it has carried all along. We have called IC 1101 the largest galaxy. But largest by what measure? And is it even still true? Out in the universe are other giants that rival it, and some are enormous in a way that has almost nothing to do with stars. If one galaxy is the largest in starlight, and another is the largest in something else entirely, which one is really the biggest? Largest sounds like a single record, the kind only one thing can hold at a time. It is not. There are several different records for largest galaxy, and they do not agree with one another, because galaxies grow large in ways that have nothing to do with each other. The contest does not have one winner. It has different winners depending on what you decide to measure. Consider a galaxy found in recent years and given the name Alcyonius. At its center sits a fairly ordinary elliptical, a galaxy that, judged by its stars, would not turn many heads. But out of that modest center, its black hole has launched two jets in opposite directions, and those jets have inflated two enormous lobes of glowing plasma reaching far out into intergalactic space. End to end, that structure spans something like 16 million light-years, among the largest single objects ever traced back to one galaxy. Laid against the Milky Way, you could line up more than 150 of our galaxies across it. By sheer reach, Alcyonius dwarfs IC 1101, stretching across several times the distance even the most generous measure ever gave the supergiant. But ask what those lobes are made of, and the comparison turns on its head. They are plasma so thin it is closer to vacuum than to any gas you could feel, a whisper of charged particles and magnetic field, visible only because they glow faintly in radio waves. There are almost no stars in them. There is almost no mass in them at all. Alcyonius is gigantic in extent and nearly empty in substance, a vast structure made of next to nothing. IC 1101 is the reverse, far smaller in reach, but packed with 1 trillion stars and the weight to match. So one of them is the largest in space occupied, and the other is among the largest in actual stuff, and there is no single scale on which both questions get the same answer. They are not competing for the same prize. They only sound like they are because we used one word for both. So the question we started with, which one is really the biggest, has no answer waiting in nature. It has only answers waiting in our choice of what bigness is. Pick reach, and Alcyonius wins. Pick mass, and IC 1101 wins. Pick the brightness of stars, the spread of dark matter, the energy pouring out, and you crown a different giant each time. This is the same lesson the edge problem taught us, returning at a larger scale. Size was never a single property an object simply has. It is something we define, and when we try to rank two very different objects by it, the definition does all the work. The universe does not hand us a ruler. It hands us things and leaves the ruler to us. Look closer at how those two giants got large, and the difference becomes almost a mirror image. IC 1101 grew by pulling matter inward, gathering galaxy after galaxy down its well, hoarding substance at the bottom. Alcyonius grew by blasting energy outward, its black hole flinging twin beams across millions of light-years, carving emptiness into something vast. One is the universe making bigness by collection. The other is the universe making bigness by expulsion, pulling everything in or driving everything out. They are nearly opposite acts, and each produces, in its own currency, a giant. And yet the two are not separate species, they are the same machine at different moments. What drives Alcyonius is a supermassive black hole launching jets, and IC 1101 has one of the most massive black holes known, sitting in its own core. We have already watched that heart, in its quiet way, blow bubbles into the gas around it to keep the galaxy sterile. In a louder, younger phase, IC 1101 almost certainly drove jets of its own, and may well have inflated giant radio lobes that have long since faded back into the dark. The collector and the ejector are not two kinds of object. They are one kind of engine, a galaxy with a great black hole, caught at different settings. Turn the engine to gather, and you build an IC 1101. Turn it to blast, and you build an Alcyonius. Often the same galaxy does both, at different stages of its life. So the crown IC 1101 has worn fractures into many crowns. Largest in starlight, when measured to a generous edge, among the most massive in stars, not the largest in extent, where the radio giants reach far further, contested in its halo, where the cluster's own light blurs into the galaxies. Each of those is a real title, and a different one, and IC 1101 holds some while losing others. The single grand claim, the largest galaxy in the universe, turns out to be a sentence that sounds like a fact and behaves like a choice. The contest only makes sense once you have already decided what bigness means, and I am no longer sure the universe ever offered us just one meaning. We wanted a champion, a single biggest thing to stand at the top of the scale. What we found instead is that biggest splits apart the moment you set side by side two things that are large in different ways. It is a little like asking whether the heaviest mountain or the widest sky is bigger. Both are honest questions. Neither has a shared answer. The objects are real and immense, and the ranking we hoped to lay over them was always ours to invent, never theirs to settle. There is one more turn here, and it cuts closer to home than the radio giants do. Even when we hold the comparison to starlight alone, even when we measure IC 1101 against other galaxies entirely on its own terms, the record begins to soften because the very tool we use to crown it, the faint light at its edges, is also the tool most able to deceive us. How much of the largest galaxy is the galaxy, and how much is the way we chose to look at it? The honest answer is that a large part of the record is the looking. The size that made IC 1101 famous rests on its faintest light, the dim outer glow at the very limit of what we can detect. And the faintest light is the least trustworthy light there is. To claim a size record, you have to push the measurement out to the extreme edge of detectability, and that edge is exactly where every source of error grows largest. Records live in the noise. 3 different deceptions crowd into that faint zone, and any one of them can inflate a galaxy. The first comes from the telescope itself. When a very bright object sits in the field, its light does not land in a perfectly clean point. The atmosphere and the optics smear a little of it outward, spreading faint wings of scattered light far beyond the true source. Around something as luminous as the core of IC 1101, those wings can reach a long way, and they look exactly like a faint extended halo of stars. Some of the size people once measured was never the galaxy at all. It was the glow of the bright center, smeared outward by the instrument doing the measuring. To find the real galaxy, You first have to model that smearing and subtract it, and how carefully you do that changes the answer. The second deception is everything else that lives in that faint zone. Out where the galaxy's light has dropped almost to nothing, it must be separated from the glow of our own sky, from foreground stars in the Milky Way, from background galaxies behind it, and from the intracluster light, those homeless stars of the whole cluster. All of it overlaps. All of it blends together at the same faint level. Deciding which of that dim light belongs to IC 1101 and which belongs to the sky or the cluster is not a reading, it is a judgment. Subtract a little more, and the galaxy shrinks. Subtract a little less, and it swells. The number you end with is partly a statement about your own assumptions. The third is built into the fact that we only ever see a flat shadow. A galaxy is a three-dimensional cloud, but we measure it as a two-dimensional image projected onto the sky. We cannot see its depth directly. An elongated giant turned to show its long axis looks far larger than the same giant seen end on, and from 1 billion light-years away we cannot simply walk around it to check. We infer the true shape with assumptions, and the assumptions feed straight back into the size. Put all three together. Measure IC 1101 the way you would measure any ordinary galaxy, with careful subtraction of the instrument's smearing, careful removal of the sky and the cluster light, and a consistent standard for where to stop, and the giant deflates. The famous span near 6 million light-years collapses toward a bright stellar body of a few 100,000 light-years, several times the width of the Milky Way, still enormous, still among the largest galaxies known by stars, but perhaps 10 or 20 times smaller than the headline that made it legendary. The 6 million light-year figure was never purely the galaxy. It was the galaxy, plus the cluster's drifting light, plus the instrument's scattered glow, plus a choice to chase all of it down to almost nothing. Strip those away, and what remains is smaller and far more certain. There is a deeper pattern in this, and it reaches well past one galaxy. A record is always a claim about an extreme, and extremes are where measurement is thinnest. The largest, the oldest, the most distant, the brightest. Each of these superlatives sits at the far edge of what the data can support, because that is what makes it a superlative. So the most spectacular claims tend to be the most fragile ones, built on the faintest signals, the longest extrapolations, the hardest subtractions. The very thing that thrills us about a record, that it stands at the absolute limit, is the same thing that makes it likely to soften when someone measures more carefully. The fame of IC 1101 rests on the single least certain number anyone ever measured about it. This is the sense in which the scale of IC 1101 really is worse than you think, though not in the direction the phrase usually points. The unsettling part is not that the galaxy turned out larger than you imagined. It is that the famous largeness is partly a mirage of method, a number that says as much about how we looked as about what is there. And yet the object beneath the mirage loses none of its strangeness. Measured fairly, IC 1101 is still a galaxy of 1 trillion old stars, still edgeless where it dissolves into its cluster, still dead, still sterile, still built from the fused remains of dozens of others. Every unsettling thing we have found is real after the headline shrinks. The deflation does not take the awe away. It moves it off a shaky number and sets it on solid ground. And the shrinking is not a failure of the science. It is the science working as it should. The first measurement reached as far as it could and caught something real but contaminated. Later measurements, more careful, peeled away what did not belong. We should trust the smaller, harder one number more than the grand one, not less, even though the grand one is the one that travels. It took me a while to make peace with the smaller number, and longer to see that it is the more impressive one. There is a habit in all of us, looking into the dark, of letting the faint edge of a thing become whatever we need it to be. Stare at the dim border of anything, right at the limit of sight, and the eye begins to invent, filling the uncertain edge with the shape it expects to find. Telescopes do a version of the same thing, and so do we, every time we repeat a number that flatters the object. The faint outer light of IC 1101 is precisely the place where the galaxy and our wishes are hardest to tell apart. The discipline is in measuring what is actually there, letting it be smaller than the legend, and discovering that smaller and true is stranger than large and uncertain. But strip the deceptive light away, shrink the visible galaxy down to its honest size, and a different question rises in its place. Because the thing that truly sets the scale of IC 1101 was never the light at all. The light is only the small, bright part we can see. What holds this giant together, what decides its real weight and reach, is something that gives off no light whatsoever. If the visible galaxy is the deceiving part, what is the invisible part actually made of? The honest answer is that we do not know what it is made of. We can tell you how much of it there is, and where it sits, and how it moves, and that it is made of nothing we have ever held or named. But what it actually is remains one of the largest open questions in all of science. The thing that defines the true scale of IC 1101 is the single most mysterious substance in the universe. We call it dark matter, and the name is mostly an admission. It gives off no light, absorbs none, reflects none. It does not glow when it is hot, or flash when it is struck. By every means we have of seeing, it is perfectly invisible, and yet it outweighs everything visible in the cluster by something like 5 or 6 to 1. For every kilogram of matter in Abell 2029 that you could see, there are several more that you cannot, and those unseen kilograms are the ones holding everything together. The remarkable thing is that we can weigh the invisible directly, using nothing but its gravity. Mass bends the path of light. Anything heavy enough warps the space around it, and light passing through that warp is deflected, the way a straight line drawn on a stretched sheet curves where the sheet sags. So the light of distant galaxies, traveling toward us from far behind the cluster, is bent and distorted as it passes through all that unseen mass. Their images reach us stretched, smeared into faint arcs, subtly pulled out of shape. By measuring exactly how those background galaxies are distorted, we can map the mass that did the distorting, including the mass that gives off no light at all. We are not inferring the dark matter from a guess. We are watching it bend the light of the universe behind it, and reading its shape from the bending. The distortion from any single galaxy is tiny, far too small to read one at a time. So the way to map dark matter is to measure the shapes of enormous numbers of background galaxies at once and find the faint, shared stretching that runs through them all. A new generation of wide-field survey telescopes is built precisely for this, sweeping across huge areas of sky again and again, recording the shapes of billions of distant galaxies. From those billions of slightly distorted images, the hidden scaffolding of the cosmos can be drawn, the great dark structures no ordinary telescope can ever see, traced out by the bent light of everything behind them. The point is not any one machine. The point is that we have learned to chart a substance we cannot see, across the whole sky, by the marks it leaves on light that merely passes by. And what those maps reveal reorders everything we have said about IC 1101. The visible galaxy, even at its honest size, sits inside a vastly larger and heavier halo of dark matter, a roughly spherical cloud of the unseen stuff reaching far beyond the light, holding the whole cluster in its grip. The luminous giant we have been measuring all this time is a small, bright deposit at the center of that halo, like a single lit window in a building that runs off into the dark in every direction. The thing we called the largest galaxy is the glowing sediment at the bottom of an invisible mountain many times its weight. Recall how fast everything in the cluster moves, the galaxies racing at hundreds of kilometers a second, the stars of IC 1101 tearing along their random orbits. The visible matter alone could never generate enough gravity to hold things moving that fast. They would have flown apart and scattered into the expanding universe long ago. The only reason the cluster exists, the only reason IC 1101 stays bound and does not simply boil away, is the extra gravity of all that dark matter, supplying the grip the visible mass cannot. Take the dark matter away, and the whole structure would not slowly relax or quietly fade. It would shatter, every galaxy and every star flung outward, the giant unmade in a cosmic instant. The most massive galaxy we know of is held in one piece by a substance we have never identified. The dark halo also gives the edge problem its final and deepest form. The light had no clear edge, fading gradually into the cluster. The mass is the same, only more so. The dark matter thins outward with no boundary either, the halo of IC 1101 blending into the halo of the cluster, and the halo of the cluster, reaching out along faint invisible filaments into the larger web of dark matter that threads the entire universe. There is no last particle marking where the giant ends, in light or in mass. The edgelessness we kept meeting in the glow was never really about the glow. It runs all the way down, into the dark structure underneath, and out into everything. The strange part, for me, is how confidently we can map a thing we cannot name. We know where the dark matter is to remarkable precision. We know how much. We know how it shaped this galaxy and holds this cluster and bends this light. We can draw it across the sky, and we cannot say what a single particle of it is. Every certainty about its presence sits beside a complete blank about its identity, the thing that defines the real scale of IC 1101. That decides its weight and its reach, and whether it holds together at all, is something we can measure with great care and still cannot explain in the least. That is the scale of the problem hiding underneath the scale of the galaxy. Almost everything that holds the large structures of the universe in place is invisible to us. The night sky we look up at, the galaxies and clusters scattered across it, is the small luminous part riding on a vast dark framework we will never see directly. We live inside a structure held together mostly by a darkness we cannot perceive, and it has been holding, steadily and silently, since long before there was anyone to wonder about it. The light is the exception. The dark is the foundation. This giant, dark and luminous together, did not always exist. There was a time when neither IC 1101 nor anything like it had yet taken shape, when the first such structures were only starting to gather out of the young universe. To see how a thing like this is born, we have to look further back than we ever have. How does a galaxy this large begin, in a universe that was once too young to hold anything so old? We can never watch IC 1101 being born. Its light shows it to us as it was 1 billion years ago, and even then it was ancient, already old, already finished with the work of making stars. The galaxy's own childhood happened too long before that light departed to be recorded in it at all. But there is a way around this, and it uses the same slowness of light that hid the childhood in the first place. To see how a giant like this begins, we look much farther away, at other galaxies, in the universe's deep youth, and watch its kin take shape. Looking farther is looking earlier, always. The most distant galaxies we can find are also the youngest, seen as they were not long after the universe began, because their light has spent nearly the whole age of the cosmos in flight. And as that light traveled through expanding space, it was stretched far toward the red, out of visible light entirely, and into the infrared. That is why the newest deep telescopes are built to see in infrared. It is the only way to catch the stretched light of the first galaxies. With those eyes, we can look back to an age when the great structures were just beginning to assemble, and watch the ancestors of giants like IC 1101 in their opening chapters. What that early universe has been showing us is a surprise still being absorbed. Massive galaxies, already large, already old, already red and quiet, turning up far earlier than anyone expected them to exist. Galaxies that seem to have built themselves and then shut down while the universe was still young. The expectation had been that big galaxies take a long time to assemble, growing slowly across many billions of years. Instead, the deep past keeps revealing giants that formed fast and finished early, dead already when the cosmos was a small fraction of its present age. The universe, it turns out, did not build its largest galaxies slowly. It built many of them almost at once, near the beginning. The way a giant like IC 1101 forms happens in two very different acts, separated by billions of years. The first act is fast and violent. In the dense young universe, gas pours together and ignites a furious burst of star formation, building a compact, intensely crowded ball of stars in a relatively short time. Astronomers call these early objects red nuggets. Because they are small, they are red, and they are almost unbelievably dense. Picture the entire stellar mass of a giant elliptical packed into a volume a few times smaller across than the galaxy we see today, the stars crammed tens of times more tightly than anything in our own neighborhood. Then, just as quickly, it quenches. The gas is used up or blown out, and the nugget goes dead, a tiny ancient ember holding the mass of a giant. The second act is the long one, and it is the slow work of everything we have already watched. Over the following billions of years, that dense old core grows not by making new stars, because it cannot, but by swallowing other galaxies, one dry merger after another, each one draping its stars around the outside of the core. The galaxy does not get much brighter or much heavier at its center. It gets larger. The accreted stars settle into the outskirts and inflate the whole thing outward, building the vast, diffuse envelope that gave us so much trouble to measure. The stars are old. The size is young. The mass was made early, in the nugget, and only gathered into its final enormous shape long afterward. The edgeless, diffuse envelope of IC 1101 is the accumulated debris of late mergers, wrapped over billions of years around an ancient, dense heart. The gold color is the light of that early, furious burst, reddening ever since. The sterility is the quenching that ended the first act. The fused black hole, the ghost ocean, the borrowed stars. All of it is the second act, the long, slow gathering, written around a core that was finished before the sun existed. IC 1101 is not one thing that grew steadily. It is an ancient small core wearing 11 billion years of accumulated remains. This answers the strange shape of the question we started with. How can a universe that was once too young hold something so old? Because the youth of the universe is exactly when the oldest things were made. The first dense cores formed when the cosmos was new, and their stars are nearly as old as time itself, lit when the universe was perhaps a quarter of its present age. The biggest galaxies did not come last. They came close to first. The oldest stars in IC 1101 are almost as old as the universe that holds them, and the galaxy around them is the slow afterthought, assembled across all the time since. So when the deep telescopes find those early red nuggets, dense and dead at cosmic dawn, they are showing us the opening chapter of IC 1101's own story. Not this galaxy itself, but its ancestors and its cousins, caught being born and dying young, in an era so distant their light had to cross almost the entire universe to reach us. We are watching the first page of a story whose final page sits a billion light-years away, already old. I cannot quite get used to the order of it. The era of creation, the great age of making, was brief and early. The universe forged its most massive galaxies in a furious opening burst, then spent all the time since slowly rearranging the results, gathering old stars into ever larger and quieter shapes. IC 1101 is a monument to a creative age the universe has already left behind. Its grandeur is not the grandeur of something still becoming. It is the grandeur of something assembled long ago, from materials forged at the very beginning and tended into stillness ever since. The largest galaxy is, in a sense, a relic of the universe's first and most fertile morning. And that is the part that turns this from a story about a distant giant into a story about us. Because the path that built IC 1101, the merging, the quenching, the slow settling into a red and lonely shape, is not unique to it. It is a road other galaxies are still traveling, including, in time, our own. What happens to a living spiral like the Milky Way when it finally starts down the same road? For a long time, the answer to this was taught as a certainty. In about 4 or 5 billion years, the Milky Way and the Andromeda Galaxy, drifting toward each other across the space between us, would collide and merge, and our spiral would be unmade in the building of something new. It was presented as fixed, a date already written into the sky. Recent measurements have softened that certainty into something closer to a coin flip. The collision is no longer destiny, but the road it points down still is, and that is the harder thing to take in. The change came from measuring how Andromeda is moving sideways across our line of sight, not just toward us. That sideways drift is tiny and brutally hard to pin down, and it decides everything, because a galaxy falling straight in will collide, while one with even a little sideways motion may swing past instead. The latest and most careful measurements put the odds of a merger within the next 10 billion years at something like 1 in 2, with a real chance the two galaxies simply pass close, tug at each other, and carry on, perhaps colliding only much later, perhaps not in any span we would care to name. What once looked like an appointment is now a probability. We were more sure of our galaxy's fate a decade ago than we are today, and the new uncertainty is the more honest picture. Set Andromeda aside, though, and the longer fate does not really depend on it. The Milky Way is slowly running down. Its supply of cold gas, the fuel for new stars, has been declining for billions of years, and our rate of making new stars is a shadow of what it once was. We are a living galaxy, but an aging one, already drifting toward quiet. And the local group, our small gathering of galaxies bound together by gravity, will over vast stretches of time draw its members inward and merge them, the way every bound group tends to. Whether or not Andromeda is the one, and whether it happens soon or late, the destination is the same. A spiral like ours does not stay a spiral forever. And when a large merger does come, everything we have watched happen to other galaxies happens to ours. The ordered disk, the gentle rotation, the arms, all of it gets scrambled in the violence of the merger, the careful turning converted into random motion, until what remains is no longer a spiral at all but a smooth, pressure-supported swarm, an elliptical. The two central black holes sink toward the new center and, in time, merge into one. Whatever cold gas the collision drives together may flare in a final burst of new stars, a last bright generation, and then that gas is spent or blown away, and the new galaxy reddens and quiets and goes sterile. The Milky Way's long story would end as a red and quiet elliptical, the same kind of object IC 1101 is, built by the same steps we have traced the whole way through. It would be a mistake to call the result a second IC 1101, though, and the difference matters. Our merged galaxy would be an elliptical, red and dead in kind, but it would hold at most 1 trillion stars or so, and it would sit in a modest little group, not at the bottom of a deep, rich cluster with hundreds of galaxies to consume. It would become the same species of object as IC 1101, not the same scale. A small, dominant elliptical in a quiet neighborhood, never fed enough to grow into a true supergiant. We are headed for the same kind of ending, only a far more modest version of it. There is a second fate waiting that does not depend on any merger at all, and it is the loneliest part. The accelerating expansion of the universe is carrying every other group of galaxies away from ours, faster and faster, and beyond a certain distance they are receding more quickly than their light can ever reach us again. Our local group is bound and will hold together, but everything outside it is slowly leaving. Over immense spans of time, the other galaxies will redden, dim, and finally vanish from view entirely, until whatever our galaxy has become sits alone in a dark and nearly empty sky, the only large thing left to see. The isolation we described around IC 1101, the sealed larder, the island of gravity in an emptying cosmos, is our future too. We are on that same road in every sense. This is what changes, for me, in how I see our own galaxy now. IC 1101 is not some alien monster, a freak the universe produced once. It is a preview, an extreme and early version of where ordinary matter tends to go. The living, blue, ordered Milky Way overhead is not the permanent state of things. It is the brief and lucky phase, the spiral morning before the long red afternoon. The giant a billion light-years away is simply much further down the same road we are walking. The road from order to smoothness, from blue to red, from making to merely holding. None of this is a threat to anyone or anything. All of it lies far beyond the life of the sun, which has only a few billion years of steady shining left before it swells and dies, and beyond the life of the Earth as we know it, which will have changed past recognition long before any merger could matter. Whatever watches the Milky Way become an elliptical, if anything watches at all, will not be us, and will not be anything that grew from here. This is not a forecast of doom. It is a window onto the deep future of matter. A future our kind of life will never reach, and was never meant to. So the next time the faint band of the Milky Way is overhead, you will know what you are looking at. A living spiral in its blue morning, still turning, still making stars, still holding the ordered shape the universe hands out only briefly. The warm, red, structureless, isolated sky we imagined from inside IC 1101 is not only a distant giant sky. It is, in the slowest possible sense, the sky our own galaxy is drifting toward, an unimaginable distance of time from now. The sky above you is the rare and temporary one. But becoming red and dead is not only a fate that befalls a single galaxy. When a galaxy stops making new stars, something larger stops with it, something that reaches past shape and color into the very substance of the universe. What ends in the whole cosmos when the last new star is made? What ends is the universe's only way of making anything complicated. Stars are not just sources of light. They are the forges where nearly every element heavier than the lightest two is made. And when the last new star is made, that forging stops. Go back to the beginning to see why this matters. The early universe was almost chemically empty. The Big Bang produced hydrogen and helium with the barest trace of lithium and essentially nothing else. No carbon, no oxygen, no iron. None of the elements that rocks and water and living things are built from existed at all. Every one of them was made later, inside stars. In the crushing heat of stellar cores, light elements are fused into heavier ones, and when massive stars die in supernovae, or when the dense remnants of dead stars collide, the heaviest elements of all are forged and flung out into space. The gas that was once pure hydrogen and helium is seeded, a little at a time, with the products of every star that has ever lived and died inside it. This is a cycle, and the cycle is what builds the periodic table. Gas collapses into stars. Stars forge new elements. Stars die and return that enriched material to the gas. The next generation of stars forms from richer gas, forges still more, and dies in turn. Generation after generation, the chemistry climbs, from 2 elements at the start toward the 90-odd that occur in nature now. Astronomers call this chemical evolution, and it has only ever happened in one place, inside the stars and around their deaths. The making of complexity in the universe runs entirely through star formation. A red and dead galaxy has broken that cycle for good. When star formation stops, the enrichment stops with it. No new stars means no new elements forged, no new material returned, no next generation richer than the last. The chemistry simply freezes at whatever level it had reached when the final stars formed. IC 1101 forged its elements early and fast, in that furious opening burst, and then it quit. Its chemical evolution did not slow. It ended billions of years ago. The galaxy is not only sterile of new stars, it is sterile of new chemistry. Whatever elements it holds now are all it will ever have. And the elements are the precondition for everything intricate. Planets need heavy elements to form. Rock needs them. Water needs oxygen, which a star had to make. Every complex molecule, every chemistry rich enough to matter, rests on the heavy elements that only stars produce. So a galaxy that has stopped making stars has stopped, in a deep sense, being able to make anything new at all. Not just new stars, but new worlds, new chemistry, new complexity of any kind. The ladder that climbs from simple to intricate has stopped on whatever rung it reached. IC 1101 is a place where the building of complexity is finished. The unsettling part is that the whole universe is walking the same path. The rate at which the cosmos makes new stars peaked long ago. Around the same era those first giant cores were forming, and it has been falling ever since. We live well after the peak. A large share of all the stars that will ever exist have already been made. The universe as a whole is doing, slowly and globally, exactly what IC 1101 did locally and early. It is running down its gas, slowing its making, drifting toward red and quiet. The largest galaxy is not an exception to the cosmic story. It is a piece of the future that arrived early, a region where the universe's long decline is already complete. Follow that decline far enough, and it reaches an end. In the deep future, across spans that dwarf the present age of the universe many times over, the gas everywhere is used up. The last stars form, burn through their fuel, and die. After that, no new star is ever made anywhere, and the forging of elements stops for good. What remains is a long darkening, lit only by the cooling embers of dead stars, the dim white dwarfs and the silent neutron stars and the black holes, fading slowly toward the cold. The periodic table is finished. Complexity reaches its peak, and from there can only come a part. The universe does not end in fire. It ends in a long, quiet fading, and the last new star is the moment the making stops, and only the fading is left. There is a strange symmetry in this that took me a long time to see. The same gravity that gathers gas into stars, that builds the complexity in the first place, is also what drives matter into the dead ends that end the building, locking it away in quenched giants and burnt-out remnants from which no new making can begin. Creation and exhaustion are not two opposed forces here. They are the same process, seen at its beginning and at its end. The universe builds, by the very mechanism that guarantees it will one day stop building. What steadies me, against all of this, is a plain fact about where the elements came from. The iron carried in your blood, the calcium holding your bones together, the oxygen filling your lungs right now, were all forged inside stars that lived and died before the sun was born. You are made of the products of that chemical evolution, assembled during the universe's long creative age. The making is finite, and one day it will be over. But it happened, and it is still happening, and we exist inside that window rather than after it. The complexity already built, including the strange complexity that can lie in the dark and think about a galaxy a billion light-years away, is real, and it will last a very long time. We are not at the end of the making. We are living in the middle of it. But the making does end, eventually, and the long fading begins, and the fading carries its own loneliness. As the universe quiets and expands, the things still visible to anyone grow fewer and fewer, until at last only the largest, nearest survivors remain in view. A galaxy like IC 1101, resting at the bottom of its bound cluster, may be among the last large things anyone left in its sky could ever see. When everything else has faded from view, what is the last thing still bright enough to watch? The answer is the galaxy that already swallowed its neighbors. When everything else has faded, the last large thing still visible to anyone inside Abell 2029 will be IC 1101 itself, and it earns that place not by outlasting the others, but by being what remains when all the rest is carried away. To see how, follow the expansion of the universe to its conclusion. Space is not only expanding, it is expanding faster and faster, and that acceleration sets a hard limit on what anyone can ever see. Beyond a certain distance, galaxies are receding from us so quickly that the space between is stretching faster than their light can cross it. Light those galaxies send out now will never reach us. They are already, in effect, beyond the edge of the observable, and as time passes, that edge draws inward, swallowing more and more of the sky. One by one, the distant galaxies redshift toward invisibility, their light stretched longer and dimmer and redder until it sinks below anything that can ever be detected. They do not move away and shrink. They thin out, redden, and quietly wink out of existence as far as any observer is concerned. But not everything leaves. Structures held together by their own gravity resist the expansion. A bound cluster like Abell 2029 will not be pulled apart. Its galaxies will keep orbiting one another, keep shining on one another, long after the rest of the universe has receded past the horizon and gone dark. So, an observer living inside that cluster in the deep future would watch the entire outside universe slowly empty, every external galaxy fading from the sky, until only the cluster's own members remained. And at the center of that surviving island, brightest and largest of them all, would stand IC 1101, the last great thing left to see. There is a bitter symmetry in how it arrives at that solitude. IC 1101 already removed its largest rivals by hand, dragging them down its well and grinding them into itself over billions of years. Now, cosmic expansion finishes the job from the other direction, carrying off everything the galaxy never could reach. Local hunger emptied the inside of the cluster. Cosmic expansion empties the outside. The galaxy that consumed everything near it ends up alone because everything far from it has also gone. It is left solitary from both directions at once. The last bright thing in a sky cleared by two completely different forces that happen to agree on the same ending. And here the deepest loss of all is not the light, but the truth the light carried. Almost everything we know about the universe, that it is expanding, that it began, that it is filled with countless galaxies, we learned by looking at galaxies beyond our own and reading the messages in their light. An observer in that faded far future would have none of it. They would see only their own cluster, an island of stars surrounded by perfect darkness, with no other galaxies to compare against, no distant redshifts to reveal the expansion, no faint glow left over from the beginning. As far as any evidence could show them, their cluster would be the entire universe, static and alone, with no birth and no expansion and nothing beyond. They would not be ignorant through any failing of their own. The evidence itself would be gone, carried beyond reach by the very expansion they could no longer detect. The truth about the cosmos is not only hard to find, it is fading. It changes how I think about looking up at all. The fact that we can see other galaxies, measure their retreat, trace the expansion back to a beginning, find the afterglow of that beginning still faintly warming the sky, is not a permanent feature of the universe. It is a privilege of timing. We happen to live in the window when the universe is still legible, when the evidence is still here to be read. Future observers, inside their bright, lonely islands, will look up at a sky that lies to them by omission, and they will have no way to know it. We are among the ones who get to see the story while it can still be told. Inside the bound cluster, the stars keep aging, and no new ones are made. Over unimaginable spans, the existing stars burn out, one kind after another, and IC 1101 fades from gold to deep red to a dull glow of cooling embers. So the sequence runs in stages. First, the outside universe vanishes, carried off by expansion. Then only the cluster remains. Then the cluster's own stars die, and the giant dims. And at last, even the final bright thing left to watch is no longer bright at all. The last witness fades, along with everything it was the last to outshine. All of this rests on the universe continuing to expand the way it does now, driven by whatever the dark energy is, and that is one more thing we do not fully understand. If it behaves differently than we expect, the far future could take another shape, and every step of this lies almost incomprehensibly far ahead, across timescales beside which the entire history of stars so far is an early instant. It is not a warning. Nothing here threatens anyone. It is a map of a future so distant that its only real effect on us is the perspective it lends, looking back from the far end toward the brief, bright, crowded moment we are standing in. What I keep landing on is not the loneliness of that future, but the privilege of this present. The sky you can see tonight, full of stars and, beyond them, full of galaxies you cannot see but can know are there, is a sky the deep future will not have. We are living in the rare stretch of cosmic time when everything is still in view, still connected, still readable. The same expansion that will one day hide the universe from its last observers has not yet hidden it from us. We arrived while the lights were still on. And that is where this whole long journey, out to a giant 1 billion light years away, and forward to the end of everything visible, finally turns back. Toward the one place all of it has been quietly leading. Not the largest galaxy, and not the farthest future, but the small, warm, living thing taking it all in, here, in the dark, right now. What does any of this immensity have to do with the body lying still in the dark, listening? The connection is not poetic, and it is not a comfort I am inventing to round things off. It is the plainest fact in all of this. The same physics that runs IC 1101 runs the body lying here in the dark. There is no second set of laws for the small and the warm. There is only one, and it does not change between a galaxy 1 billion light years wide and the person quietly breathing in a dark room. Start with the most familiar force, the one holding you to the bed. Gravity. The same gravity that holds 1 trillion stars in their slow orbits, that keeps IC 1101 from flying apart, is the force pressing you gently down into the mattress right now. It is not a larger or a different gravity out there. It is this one. And the way the giant holds itself open against that pull is the same way you do. IC 1101 does not collapse because the motion of its stars pushes outward as hard as gravity pulls in, a balance held steady for billions of years. Your body rests on the bed for the same reason. The atoms beneath you pushing back exactly as hard as gravity presses down. The giant and the body are both held open by the same standoff between falling and resisting. Neither one is truly still. Both are a stillness made of motion that happens to cancel. now the matter you are made of. The iron in your blood, the calcium in your bones, the oxygen moving through you with every breath, were forged inside stars and scattered when those stars died, long before the sun existed. They are the same kind of atoms, made the same way as the stars that fill IC 1101. The giant is built from the products of stellar fire, and so are you. There is no material difference between the stuff of the largest galaxy and the stuff of the hand resting on the blanket. You are made of the same forged elements gathered here into this shape for a little while. Listen to your own heartbeat for a moment, the steady rhythm of it. That steadiness is not rest. It is a balance held, the same kind of balance that holds the giant, your heart, your breathing, the even warmth of your body, are all equilibria, states kept open against collapse by a constant quiet flow of energy. IC 1101 holds its shape as a steady state that could outlast the universe. You hold yours as a steady state that lasts a lifetime. The scales could not be more different, and the principle is exactly the same. A balance maintained against the pull towards stillness. Your calm tonight is not the absence of motion. It is motion arranged so finely that it reads, from the inside, as peace. Feel the warmth of your own body against the cool of the room. That warmth is slowly leaving you, flowing out into the dark, the way heat always flows from the warm toward the cold. It is the same one-way flow that reddens the giant and carries the whole universe gently down. And yet you stay warm, because your body keeps restoring what it loses, holding its temperature steady against the drift, the way every living thing borrows a little order from the world to keep its own. The great rule that carries the cosmos toward its long fading is running in you right now, in the simple warmth you are giving to the night. You are not exempt from the physics that ends galaxies. You are a small, warm, finely arranged instance of it. Even seeing obeys the same rule we met at the very beginning. The billion-year-old light from IC 1101 reaches you out of the deep past, and you cannot see the galaxy as it is, only as it was. But this was never unique to the giant. The light from your own hand, lifted in the dark, reaches your eye a fraction of a heartbeat after it leaves, so that even your own hand is something you see slightly in the past. Looking at anything, near or far, is always looking back in time. The galaxy only takes that quiet truth and stretches it across a billion years. You live inside the same light, on the same terms, only closer. So here is what all that immensity has to do with the body in the dark. Everything. The largest galaxy we know is not a foreign thing in a separate universe, ruled by grander laws. It is a distant relative, running the same rules that run you, made of the same forged atoms, held open by the same balance, carried by the same slow flow of time and heat. Understanding it was never meant to make you feel small. It was meant to show you the seam is not there. The immensity and you are not two things. You are a local, warm, brief, waking expression of the very physics that holds a trillion stars a billion light-years away. And that is a reason to rest easy, not a reason to feel lost. The laws that have held IC 1101 steady for billions of years are the same laws holding you steady tonight, and they are utterly reliable. Gravity will not forget you. The balance that keeps your heart beating does not depend on your watching it. The order is not fragile, and it is not yours to hold up. You can let all of it go for the night, the giant and the cluster and the dark between the galaxies, and the physics will keep running just as faithfully while you sleep as it has across the whole age of the universe. We went a long way tonight, out to a galaxy so large its edges dissolve, down to the one true edge at its heart, back through the deep past where it was born, and forward to the end of everything visible. And all of it comes back to here, to the quiet, ordinary, remarkable fact of you, lying still, made of forged starlight, held together by the same patient laws that hold the largest things there are. Thank you for staying with me through all of it. It means more than I can easily say, that you would spend these hours letting the universe grow a little larger and a little less frightening alongside me. There is nothing left for you to carry now. You understood something true, and that is enough. You can set it down. Rest well. The stars will keep their orbits without you tonight, and the giant will hold its long, steady silence a billion light-years away, and the same gentle gravity that holds them all is holding you, here, safe, in the dark. Good night.